Okay, so for well over a decade now, we've all been hearing about this material. A material so insane it sounds like it's straight out of science fiction. It was something that promised to change our entire world. This is the story of graphene, and why it might just be the greatest broken promise in modern science. I mean, just get a load of these stats. The numbers are just staggering. Try to imagine something that is over 200 times stronger than steel. And we're not talking about a little improvement here. We're talking about a whole different league. This is a material that can handle forces that would literally shred anything else we use. And that's graphene.
And while it's ridiculously strong, it's also ridiculously thin. So, how thin are we talking? Well, a single sheet of it is 1,000,000 times thinner than a single human hair. It's not like a two-dimensional material, it is a two-dimensional material. It's just a single perfect layer of carbon atoms.
And, as if all that wasn't enough, it's also the best conductor of electricity and heat we have ever discovered. It's super lightweight, it's flexible, you can basically see right through it, and it moves energy like an absolute superstar. By every single metric, this stuff is a true wonder material.
Which, of course, brings up the really obvious question, right? If this material is so perfect, why aren't our phones charging in literally seconds? Why don't we have cars that are feather light or solar panels that are wildly efficient? Whatever happened to that graphene revolution we were all promised?
Well, to really get the problem, we have to go back to the beginning, to its brilliant and almost comically simple origin story. See, this Nobel-winning material didn't come out of some billion-dollar super collider. Nope, it came from a roll of Scotch tape. The method they came up with is almost hard to believe it's that simple. Back in 2004, a couple of scientists at the University of Manchester took a chunk of graphite, yep, the same stuff that's in your pencil, and they just used a piece of Scotch tape to peel off a layer. Then they folded that tape over on itself, peeled it apart again, and just kept doing that over and over until they were left with a layer so unbelievably thin it was just one atom thick. That's it. That was the moment. They had isolated graphene, and it won them the Nobel Prize. But that beautiful, elegant simplicity in the lab, well, it turned into an absolute monster of a headache for industry. The very thing that made graphene so amazing, the fact that it's only one atom thick, also made it a complete nightmare to produce at any real scale. And here's where the dream just completely fell apart. Look, it's one thing to make a tiny, perfect flake of this stuff to look at under a microscope. That's easy. But trying to mass-produce a sheet the size of a TV screen, that's a whole other beast. Imagine trying to print a perfect sheet of something that's only one atom thick. The tiniest rip, the smallest imperfection, and poof, all those magical properties are just gone. For years, that one single problem basically killed all the hype.
So, the graphene story kind of went dark for a while. It became this cautionary tale about scientific hype. But now, after all these years out in the wilderness, there are some serious signs of a major comeback. And it's all thanks to a huge breakthrough in how we actually make this stuff.
The big game changer is a process called chemical vapor deposition, or CVD for short. So instead of trying to peel graphene off of something, this method actually grows it. You take a gas that's full of carbon, you pass it over a surface, like a sheet of copper foil, and it deposits a perfect, continuous, single-atom layer of graphene right onto it.
Man, what a roller coaster this has been. After that 2010 Nobel Prize, the hype just went into overdrive. But then the 2010s became what everyone calls the trough of disillusionment, when that manufacturing nightmare really kicked in. But now, companies are finally perfecting something called roll-to-roll CVD. Think of it like a giant newspaper press, but instead of ink on paper, it's continuously printing huge sheets of perfect graphene. This could be the thing, the technology that finally makes industrial-scale graphene a reality, maybe around 2025 or 2026.
So, if we really are on the verge of cracking mass production, what does that actually mean for us? It means all those wild, world-changing promises we heard about a decade ago, well, they're suddenly back on the table.
We're talking about batteries that could charge your phone in seconds and last for weeks. We're talking about water filters so precise they can pull the salt out of seawater with almost no energy. Composite materials for airplanes and cars that are impossibly light and unbelievably strong. And yeah, even that old science fiction dream of a space elevator. A cable stretching all the way from Earth to orbit, which is something only possible with a material as strong and as light as graphene.
So that brings us to the big question, doesn't it? After all the hype, all the excitement, and all the heartbreak, are we finally on the cusp of the graphene age?
Or is this stuff just doomed to be one of those technologies that's always just around the corner, forever the material of the future? You know, this time, thanks to a whole new way of making it, the answer might actually be different.